Today we'll be verifying subdivision and stability requirements. During this part of your inspection, you're going to be wearing the standard Marine Inspector PPE. General hazards are more of your trips, slips, falls, pinch hazards as you're looking around the ship. Now from other modules you've already taken and other training you've received, you may have learned a little bit about different types of hull vessels. Type 1, Type 2, Type 3. For different types of vessels, there may be variants on how they say them. Typically speaking, for these types of vessels, Type 1 is your most protective vessel, Type 3 is your least protective vessel. For the vessel that we're on today, Type 1 equivalents would be having a lot more damage stability protection and protecting the cargo and the ship from damage scenarios. Talking a little bit more about the spacing and bulkheads of your damage stability constraints, we're just going to use the fire control plan as an example. When you're looking at this diagram, you at least get a sense of how large the spaces are by frame numbers, and you get a relative scale. When you look into the requirements for each type of vessel, you'll get a scope of how big those compartments can be for your stability requirements. As long as you're able to work through each type of vessel and identify those stability requirements, you can match them up with the plans that you're seeing or what you're observing on board the vessel during your inspection. Okay. As you're walking around the ship itself, you can take what you've learned on some of these plans and take a quicker look at what the actual observations of the ship are, what the condition of the vessel is with regard to subdivision and stability. You want to pay attention to watertight doors, make sure they're fully dogged. We often see light coming from gaskets or on basically improper contact on the knife edge of gaskets of quick acting watertight doors. You can look at scuppers, you can look at drain plugs, you can look at the corrosion or material condition of bulkheads. Make sure that the insulation that's required to be there for that type of fire protection is all comprised within the bulkhead and the doors or the systems that you're looking at. Cableways are also a really big hit for us on inspections. We're always looking at through bulkhead penetrations to see if it would cause a risk to the subdivision of stability or fire. So if you see a cableway, a pipe run, or anything like that goes through a bulkhead, you can always start with looking at some of the plans, determine if that's supposed to be a bulkhead for stability or fire, and then you can observe if it has daylight coming through it or has the proper gaskets. And these are all things that you'll continue to develop judgment and experience as you're moving along with your training process. Now, one other thing you'll see on other vessels for stability concerns are your side shell openings. During other modules, we've discussed this for other reasons, but for stability purposes, things like roll-on, roll-offs, or accommodation doors for cruise ships, or container ships, all of these enclosures on the side shell are critical that they are kept in a good condition to maintain the watertight integrity of the hull. All right, when you're also looking at damage stability and the overall stability of the vessel, you can also look at the approved loading manual. When we're looking at this as marine inspectors, we're actually not looking at too much ourselves because it's very technical. But what we do want to see is that the approved class society has reviewed, examined, and approved these loading manuals. And that's really important because I am really not qualified to go through this manual and tell you what the content is. But I know that somebody much smarter than me has gone through this manual with great detail and approved this for use by the vessel. In the manual, well, I'm not going to go too much into detail, but it will give all the sequences of events to be able to load, discharge, or trim the vessel, and it will also give you damage stability constraints if ever anything were to happen. In this module, we verified subdivision and damage stability requirements. Trainee recalled any hazards, cautions, and/or PPE when verifying subdivision and damage stability requirements. Trainee determined requirements for subdivision. For example, Type 1, Type 2, Type 3, or simplified. Trainee verified bulkheads are spaced and installed per applicable subdivision type. Trainee verified presence, integrity, and material condition of subdivision bulkheads, penetrations and valves, material condition, and watertight doors. Trainee verified presence, integrity, and material condition of specialized subdivision spaces as applicable. For example, collision bulkheads, aft peak bulkheads, machinery space bulkheads, shaft tunnels, stern tubes, bulkhead deck. Trainee verified that requirements for damage stability are met. Trainee verified integrity of openings in the side shell below the bulkhead deck. Trainee described any tips or unique considerations when verifying subdivision and damage stability requirements. If you have any questions or concerns, reach out to your local verifying officer.